So we're going to jump back in talking about the last thing that we talked about in class, which is the budget line or the budget constraint. So budget constraint, budget line means the same thing, right? So we're told to consider the following budget line. We're given 100 is equal to 1 times x plus 5 times y. So we are asked, firstly, what is the maximum amount of x that can be consumed? So let's just do that real quick. I'll walk around and make sure we're getting the algebra here. What is the maximum amount of x that can be consumed? So if we want the maximum amount of x, how much y would that be if we had the maximum amount of x? So what do we want to plug in for y? What does the maximum amount of x imply? Yeah, that makes sense. Okay. So this is also the X-Intercept if we're drawing the budget line. So if we have all of x, what does that mean? How much of y do we have? That would be if we had 0x. You just calculated the maximum amount of y. Because essentially what you did is you said let x equal 0, and you solved for y. Do the opposite. So if we have all of the x, how much y does that mean? So draw your like L graph. What goes on each axis? So when it's a budget line, it's a good y on the y-axis, and a good x on the x-axis, just like yep, y and x. And so if we're talking about the maximum amount of x, right? That's that intercept there. How much y is there? What's the y value when you're on the x-intercept? 0. 0, yeah. But, I mean, just like the value in the corner is 0, 0, right? The origin. Do we know what that means? The origin. The origin is 0, 0. It's the middle of the cross. So go ahead and draw your L. The big graphing L. And then put the different goods on there, right? Put y and x. So if we're asking for the maximum amount of x, that means we're asking for the point right here, right? So how much y is there when we're on the x-axis? What would y be equal to there? So y is the amount of how high it is from the x-axis, right? That's what y is telling us, right? So this would be 1. If we, 1 or 2, 3, right? You know what I mean? So if it's on the x-axis, it's 0, right? Y is equal to 0. Not cooking?
Can you explain to me?
When you are on the, I'll do it first. So with these things, it helps to have a graphical representation, right? So we're going to go ahead and draw our big L, right? Which again, this big L, what is this thing? It is the Cartesian coordinate plane that you guys have been working with your whole entire lives, right? Where this is the positive values, this is the negative over here. So we're just dealing with this first part of the Cartesian coordinate plane. And this part that's in the center here, that's called the origin, and it's 0, 0. It's where the number line starts. And so when I'm asking you for the maximum amount of x, what I'm asking you for is I'm asking you for the x-intercept. And at this point, our x and our y are 0, right? Both of them are 0. This is our x, and this is our y. At this point, we've got 0x, but 1y. 0x and 2y. 0x and 3y. Now we're used to seeing the coordinate pairs out here, right? Where it's 3, 3, right? Where 3 is the x mapping, and 3 here is the y mapping, right? So we go up 3 for the y, 1, 2, 3, and over 3, 1, 2, 3 for the x in order to get this, right? So Uchi, what would this point be right here? 0, 1, or would it be, why would it be 0, 1? This is 0, 1 right here. How could we have two 0, 1s? So this is going to be 1, 0. And this is going to be 2, 0. This will be 3, 0. And so this thing that I'm looking for, right? I'm looking for my maximum amount of x, and I know, just like every other point that's on the x-axis, that that's going to have a y value of 0. Gesundheit. Gesundheit. So the way that we calculate the maximum of x is to plug in 0 for y. So if we let y equal 0, what does this equation become? X is just equal to 100, right? Whenever we put 0 into any term, right? So if we say 100 is equal to 1 times x plus 5 times 0, 5 times 0 is always going to equal 0. So this whole term, this plus whatever, just gets dropped out. And then we have 100 is equal to 1x, or just 100 is equal to x. Does that make sense, Suchi? So this is going to be 100, 0 as my maximum amount of x. So now let's go ahead and calculate what is the maximum amount of y that can be consumed. So for this, we're asked for the y-intercept, right? We're looking for this value here, my y max, comma, or sorry, 0, comma, y max, bleh, my y max. Say that 5 times fast. So we're going to plug in 0 for x. And so this gives us 100 is equal to 1 times 0 plus 5 times y. 1 times 0 is just 0, so we cancel out that whole term. We're left with 100 is equal to 5y. So what does that give us as y?
Oh,
it's okay.
You want, okay.
No worries.
Divided by 5 from both sides.
Yes, very good. So we end up with 20. So that's our point right here, 0, 20. And now the last thing that we're asked what is the trade-off between x and y? So what's the rate at which the market trades goods and y, goods x and y? And I will write the formula down here again for you guys. So we got negative 1/5 as our market rate of substitution, plugging in the price of x on the numerator and the price of y on the denominator. Why is it negative? Because I got to give something up in order to get something else, right? There's scarcity, right? We live in a world of scarcity. So, you know, it's always going to be negative when we're talking about a marginal rate of substitution. This is the slope of the budget line, right? Which is painfully obvious to us if we realize that the intercept over here is 20 and the intercept over here is 100, right? The x-intercept would have to be 20 in order for the slope to be 1. The slope would be 1/2 if the x-intercept was 40. The x-intercept is 100, so the slope is not 1/2, it's 1/5. 20 divided by 100. It's your rise over your run, right? So think about our full rise is equal to 20, and our full run is equal to 100. And so that's why we end up with a slope of negative 1/5. And the rise is negative 20, right? Because it's going down, obviously. So, you know, if I saw that it was like this, right? If it was green instead and my intercept here was 40, well then I would know that the slope would be negative 1/2, right? Because the rise would still be negative 20, but now the run would be positive 40, right? And we know that slope is equal to rise over run. So it would be negative 20 over 40 equal to negative 1/2 if that was our x-intercept, which is not, but just saying. So let's put them all together. Let's put them all together. Real quick of our review of indifference curves. So this still has good x and good y over here, right? Our indifference curves are telling us different levels of satisfaction. So, for instance, if I were right here and consuming this much y and this much x, and then I moved to consuming this much y and this much x, how would that impact my satisfaction as a consumer? Bimo.
We get more of X and less of Y.
But would I be more satisfied, less satisfied, or the same amount of satisfied?
For which good though?
Just my total enjoyment of goods.
So it's going,
Less.
yeah, you are saying it's going from Y down or up?
Okay, so I'm just testing to see if you guys have the general gist of indifference curves, which you don't. So indifference curves are the notion that you don't care between either point, right? So you don't care if you're up here consuming this much y and a little amount of x compared to being down here and consuming that much of y and a lot of x. Indifference curve means that I'm just as happy anywhere along this curve. So my consumer happiness doesn't change at all when I move along an indifference curve. But what happens when I jump to a different indifference curve? Well, now here we're consuming the same amount of y before, right? But instead of only this amount of x, we're consuming way more x. So it's just patently obvious if they're both normal goods, I'm happier off on this second indifference curve, right? And then this third indifference curve, I'm happiest, right? That's even more of the stuff. So the further away I get from the origin, right? Where's the origin? The origin's right here, 0, 0. So the further away I get to the origin, the better off I am as a consumer. Questions on that? So this is the beginning of the chapter having to do with that completeness theorem, right? You know, essentially that we assume that consumers know if they prefer something to another thing, or they might be indifferent, right? Like there are some times where I'm totally indifferent between, you know, going out or staying in and watching a movie or something, right? You know what I mean? Like I'm indifferent, it doesn't matter. So sometimes you might be indifferent between an extra t-shirt and, you know, ice cream sandwiches, right? You might be like, whatever, I'm different. It's up to you if you're shopping with, you know, a family member or something like that, right? So, but as we go to more northeast indifference curves, right, as we go further away from the origin, that means that we're getting more and more stuff, right? Okay.
Does that also mean like we're spending more?
Very good question. Yes, so that's the other part of it. Why wouldn't we always just chill on I3 then, right? Why, you know, so we got to put it together. We are constrained by our budget line. Very, very good. Thank you. It's a very good segue for our next part. I got chills, Beamal. Thanks, man. I feel alive again. All right, so we've got this budget line, right? And so we'll stick to the budget line that we had before, where we had a 20 maximum on the y and 100 maximum on the x. And so what's happening is that there are actually a million of these indifference curves, okay? So we only really draw a few of them, but I mean, if I wanted to, I could draw, there's like a whole bunch of them in between. So there's like a whole ton of them. It's kind of like a topographical map, right? And so we're not going to model all those each time because it's messy and you know what I mean, but they are there. They are there. So just to be aware of that. And so let's just, for instance, let's just have one and a second one. So right now, we have this budget constraint, right, that talks about how we only have $100, X goods cost $1, Y goods cost $5. What are we going to do, right? How many of the Y and X goods are we going to consume? And so right now, we find that we can consume, so at this point, we're probably clued in that, like, okay, it's going to be somewhere where they cross or they touch or something, right? Like, that's the economics. It's all about, like, curves and X marks the spot and where do they meet, right? And so, we could think about this point right here, right? The person, they're spending all their budget, right? They're on their budget line, so they're spending all the $100, and we're assuming there's no savings in this economy, right, when we're talking about consumer choice. So we're assuming that they're spending it all, but are they happiest, right? No, we know that they could be at this point, right? And they would be on a higher indifference curve. So you would get more utility or happiness from a consumption bundle on I2 than I1, right? And so similarly, there's going to be an I3, and then there's going to be an I4. And this I4 is the golden child, right? This is the one that we really care about. So why do we care about it? Because, and this is the law of large dots, because you can see here that I actually didn't touch them. But this is the law of large dots, which is a great teaching tip if you guys ever get suckered into being a teacher. You just go ahead and you just make that dot big enough so that they do connect. So these curves are connected, but only at one point, right? I can't actually go anywhere else on this curve and still be inside of my budget set, right? We know that all of the points that are in here are all possible given the amount of income that I have, right? I've got $100, I want to spend it all, but I also don't have to. So the indifference curve is that other side of the equation, right? Otherwise, we don't know where to actually consume. And the budget line is the other side of the equation when it comes to your consumption choice, because of course you're just going to want to consume at higher and higher and higher indifference curves, right? I-19, right? But you don't have the budget for that. You don't have the income yet. So you cannot consume any of these amounts here, right? You would like them. They would make you happier than if you were on I-4, but you can't get there yet. Does that make sense? Yeah. So what would happen if your income were to increase? So there's a lot of inflation going on right now, right? So food prices are more expensive and used cars are more expensive and gas and everything's more expensive, right? So part of that means that, we need to get paid more, right? The cost of living is going up, so, we need to negotiate for higher wages for ourselves, right? So let's say that we go ahead and we negotiate successfully for some higher wages. Well, what's that going to do to my budget line? Very good. It raises, right? It shifts parallel. So long as they're both normal goods, it's going to shift parallel, and we will be able to be on that I-19 or whatever. Oh, don't do that. That'll crash you. So we will be able to be on that I-19, maybe. You can just start from here. It's a little bit easier. So this is our new budget line. And on this budget line, we do have a point where the market rate of substitution, right, which is our having to do with our budget line, right? So the market rate of substitution, which we calculated earlier today, right? So for this one, we know that it's negative 1/5, right? Because even the budget line shifts out, but it's parallel, so it's going to keep the same slope as before. And so this point here is where the marginal rate of substitution equals the market rate of substitution. So this also means this is the point where our MRS is equal to the price of X over the price of Y. So this is the point where their slopes are the same, right? And this is the slope of my budget line, and the MRS, that's the slope of my indifference curve. So that's talking about my consumption choices. It's talking about how much do I value myself. How much do I value good X compared to good Y? Whereas the budget line is talking about the market. How much does it actually cost if I want to substitute out good X for good Y?
So if this was an inferior good, I think in the books it says like, then they'll increase like X and then we'll have to give up Y.
Yes.
So then how does the whole situation happen, like, graphs?
Very good. We'll definitely do that right now. Perfect. So, awesome question. So like I said here, right, we're assuming that both of these goods are normal goods. And so this is what that question was in your Kahoot, right, which was it started off here, and then, well, it was a little bit different because the question in Kahoot just had a price decrease in good X, and this is essentially either a price decrease in both goods or a doubling of your income, right? But the point is the same, that you're going to be buying both of these, more of both of these goods, so that tells me that both of those goods are normal goods from the way that I drew it. So let's go ahead and draw it if one of the goods, X, is an inferior good.
The question in Kahoot, wasn't it like for complementary goods, so, right?
Yes, it was, yes.
So then, okay.
Yes. So yeah, a little different. So we start off with an initial income something like this. I'd like to make that. Let's go ahead and just do 10. 1, 2, 3, 4, 5, 6. So just a simple 10, 10, slope of 1, 1. So just a slope of -1. So we start out here, and we start out with an initial indifference curve that goes something like this. So this is my I naught. Oh, that's probably not the best place to put it. Nope. Oh, I want to redo now. How do I do that? Oh, I just redo it. Okay, that's fine. And then we have a shift outwards because of an increase in my income. So let's say I get a 50% raise. 1, 2, 3, 4, 5. 1, 2, 3, 4. Of course, I did it off the charts here. So why would I make it easy? Okay. So this is our new income at 15, 15. And so here, so it's the shape of the indifference curves, really. So it's the fact that there's the other indifference curves
they don't have to stay parallel to this. They can change shape. And so essentially, there's an indifference curve that's up here. That's my I1, right? If we go, and then this is my B1, and then this is my B0 for budget line. And so now we're at this new equilibrium, right, where the MRS, which has to do with the slope of the indifference curve, is equal to the market rate of substitution, which has to do with the slope of the budget curve, right? So they're both going to be equal to 1 at this point. So we know that my MRS is equal to my, I'll get it backwards if I don't look, PX over PY, which is all equal to 1. Or negative 1. So this new equilibrium gives us so the book labels this, so this is all figure 4-12 that I'm modeling for you guys. From page 117. And so this is point B and this is point A, and we see here that we start off with X0, and we end up, even though there's an increase in our income, we end up with X to the 1, which is less X, and then we end up with more Y. So again, it's the fact that there are other indifference curves. There's a whole bunch of them, right? And they don't need to all follow the same exact pattern. They just can't cross over one another. But there can be, you know what I mean? There can be a whole bunch of indifference curves. And the shape of the indifference curve, you know, I mean, in a way, it tells us what goods are normal and what goods are inferior. That's a good question. So yeah, so important point for the test and stuff like that, right? This will be on the test, but there's a more complicated version that talks about this kind of stuff, where it talks about the income effects and the substitution effect. That's not going to be on the test. These things are not going to be on the test. And so last but not least, and we can continue this on Friday if you guys like, so talking about how do we model buy one, get one free sales, right? So we know from our quiz they're not the same thing as a 50% reduction, but how do we actually model them? So let's go ahead and do that real quick in the next minute. So if we have all of the other goods over here, and we have pizza right here, and there's a sale, right, that's buy one large pizza, get a large pizza free, then we start off with this budget line here. And at point C, nothing's changed because we're going to say this is going to be one pizza and this is going to be 1/2 pizza, right? So at point C, nothing's changed because at point C, we're just thinking about ordering a half of a pizza, right? And so number one, we have to assume that you can even order a half pizza. I mean, you can order pizza by the slice, right? But like at some point, you know, you're buying 4 slices, you might as well just buy a pizza, right? It's probably the same price. But anyways, so it's not going to impact your decision if you only have half of a slice, half of a pizza, right? Because it's a buy one, get one sale for a full pizza. So once we get to that full pizza, that's when this budget line takes a can jigger. And so this goes out to wherever the 2 pizza is, and then stays parallel to the original budget line. So we started off, we were on this type of indifference curve. Or let's say if this is our indifference curve and we're at C and we're maximizing, you know what I mean? So let's say, so this is before the sale, right? And that's, so I'm going to end up, you know, buying half a pizza, or maybe not even, I might not even buy pizza, right? Because essentially my indifference curve doesn't link up with my budget line above 1 slices of pizza. But as a result of this sale, we're able to get on a new indifference curve that's on this furthest most kink over here. Okay. And this is after the sale. So you have induced people to buy more pizza by getting them on a higher indifference curve given their existing budget constraints. All right, so we'll pick up in class here on Friday. Your homework for Friday is to send me at least 1 question from the text or Connect that you'd like me to go over in class on Friday, and we will go ahead and work on this a little bit more just to finish off that that learning objective, whatever it is, learning objective 6. So learning objective 6. So we skipped learning objective 4 and 5, and we're just going to do learning objective 6, and we're skipping learning objective 7 too. Did I say that at the beginning? I think I did. Yeah, 1, 2, 3, and 6. So we're going to finish 6 on Friday. Woohoo! Yay!
So we're meeting on class on Friday?
What?
We'll be in class?
Oh yeah, we're having class Friday the rest of the semester.
Okay.
Yeah, absolutely.